My name's Craig Thomas, and I am a lecturer in environmental governance. I teach at University of Manchester in the School of Environment, Education and Development. And I'm going to talk today about sustainability, and specifically my module, which is currently called Space and Sustainability. So it's a 15-credit option, which was originally set up for the Environmental Governance Masters 3 years ago now. It's in its third year. And in the second year, it became part of the MSc Climate Change, Science, Society and Solutions as well. These are a really interesting cohort of students because the masters are situated in geography, in the geography department, but actually the students come from all over the world, of course, but also from a range of backgrounds. So we have like environmental science, arts degrees, but also quite a lot of engineering students as well, and kind of systems thinkers as well. So it's a real range of backgrounds that people come to do this course. And so my Space and Sustainability course was originally called the Geographies and Environmental Governance of Outer Space, which came out of this recent literature in geography called Around the Geographies of Outer Space. But as it developed through the first year, I realised it was much more kind of interdisciplinary, which I'll talk about now. And so this year I renamed it Space and Sustainability. From 2025, it's actually a core module for the Year 4 Aerospace Engineering MEng students, specifically in the space stream. And in terms of the teaching team, it's an interdisciplinary team. They come from human and physical geography, aerospace engineering, material sciences, and I've been getting a guest industry speaker as well to come and speak. Okay, so in terms of how we teach, so it's the kind of 3 pillars. We've got the 2-hour lectures each week. We've got 12-week semesters, so there's 12 sessions. And I also add a kind of 1-hour interactive seminar. These are always a work in progress. They include things like kind of stakeholder mapping, the VR overview effects. So you're probably all aware of the overview effects, and so we talk about perspective and astronauts seeing the Earth from space and that kind of shift. So there's if you haven't used the VR headsets and you're coming to the space conference, I've actually taken a headset, and there's a really nice documentary called Space Explorers, which is free, and it's on the Meta headset. It's amazing. They set up VR cameras inside the space station, and then they took them on spacewalks, and they were so popular, and then they did a series of spacewalks. So basically, one of our seminars, the students put those on, and they go on a kind of spacewalk, and then we kind of talk about that in relation to the lecture we did. We also do the obvious discussing key papers, and I do a kind of policy role play, which is based around UN. I'll talk about it in a minute. A particular UN session, basically, and they all kind of take different perspectives on space debris. The assessment, again, so I've tried, because recognising this is a very kind of interdisciplinary topic and also cohort, I've tried not to do the kind of classic essay that we do in geography, and also, as been discussed, AI is a kind of ongoing problem, or a reason for me, in my opinion, that we should be moving away from things like essays. So the first project assessment that we've run for the first 3 years is a Wikipedia entry. So I actually asked them to look at, basically Wikipedia is great to do with outer space, but it's understandably very technical, often quite a kind of engineering and physics and different perspectives. So I say to them, please can you have a look at some of the theories we've used, and maybe incorporate some kind of environmental aspect or kind of a governance aspect. And that's been really successful. From next year I'm actually switching it to a poster, partly because of the engineering students that are coming in, but also because I'm running out of Wikipedia pages. And but that's been really, really useful for them, because it's kind of communicating ideas to a non-academic audience, which I think is important. We also do a 2,000-word policy report, taking a theoretical framework and drawing on examples. We kind of look at examples for the Wikipedia entry as well. And then once the assessment's done, then we do a field trip, and we do a day trip basically to Jodrell Bank. And that, I got funding through the Student Experience Fund. I think it's something we have in the different schools. And so Simon Garrington kindly offered to do a kind of behind-the-scenes tour of Jodrell Bank. He took us and showed us the Faraday cage and so on and so forth. It was really interesting. And the students really liked it. I thought it was good to do it after the assessment, so there wasn't that constant question of like, oh, is this going to be part of the assessment? Actually, I think what I want to get across in this kind of talk is that it's not really about the assessment so much. It's much more about kind of putting them into that kind of, making them more interested in the topic and to think about this, for me. I don't want to go through the intended learning outcomes, but I thought I'd just pop them on there in case the slides are shared. Broadly, just kind of, knowledge and understanding, but also, again, that thing about moving away from the essay, I try to encourage them to talk about their ideas and to kind of discuss things together from the different perspectives as well. Okay, so space and sustainability. In terms of how we kind of engage with sustainability, it's stating the obvious to everyone in this room, I imagine, but if you care about sustainability and, for example, sustainable development goals, then technology like low Earth orbit satellites are critical in meeting those goals. For example, in supporting climate change, disaster response, global monitoring. You've probably all seen this before, but the UN outcome and agenda, they have a policy brief 7, which is really interesting because it talks about all these kind of connections. And this is actually, you can't really see it on there, but it's actually looking at the different sustainable development goals and how outer space is connected to those. So we also kind of look, particularly in the kind of material science lecture, about the role of space technologies on Earth. Solar panels, different technologies, but also thinking about sustainability in space and what that actually means in terms of, for example, the space station. And a lot of this area of discussion is about addressing the kind of dismissive space isn't important to me. And it's quite interesting that people from all the different backgrounds, these students, the people who come on the course, at the end, the student feedback, is consistently at the top of the modules across these two masters. Like, the students really, really like it. But the hard part is getting them onto the masters, onto the course, because onto the module, because they really don't see space as something that they should be thinking about. It's very much seen as kind of, well, that's what rocket scientists do. It's not. And then, so actually, we have some really interesting discussions at the beginning about that, like kind of why are we going to space. So we also talk quite a lot about space sustainability challenges, and I've separated those first into kind of in space. So I say this is, I mentioned the policy brief, United Nations. This is very much concerned with sustainability in space, thinking about where it talks about the kind of environmental issues. So we've got orbital debris, of course, space junk, but also planetary protection and contamination, extractivism beyond Earth, so thinking about rare earth materials, for example, and this kind of speculation on how we could, in the future, mine asteroids or possibly the moon. Sustainability of space-based geoengineering. So we've got Rob Bellamy in the department who does his research around kind of geoengineering, and he's recently become quite interested in space-based geoengineering as well. So he comes and does a lecture. And also kind of governance and equity in space futures. So thinking about off-Earth resource governance, access and benefits as well. So the second part of that is thinking about the kind of local and global sustainability challenges as well. So of course, we think about sustainability in space, in terms of space debris, but you can also think about it with a kind of broader perspective. And I think this one's quite useful with the engineers, and kind of like having that maybe a broader discussion than they'd had before. So environmental and social impacts of spaceports. A really obvious example, you could give a few, because the Cosmodrome's got some fantastic examples, but also you think about SpaceX and Boca Chica, and kind of they've had privatised the beach because of all the kind of explosions and the debris and so forth, but also impacts on kind of local ecosystems, on land use. We also talk about kind of re-entry in Point Nemo, and kind of a best practice at the moment, for example, like what we do with the space station, we'll just put them into the sea and kind of talk about that. Launch emissions and upper atmosphere pollution, so we kind of look at some of the papers around that, some of the recent discussions. The re-entry effects on atmospheric chemistry and ozone, We also look at impact on astronomy, and that's something that when we go to Jodrell Bank was really interesting, kind of talking to Simon about that. But also we have a lecturer who specialises in indigenous astronomy, particularly in Australia, so they kind of talk about the impacts that the satellites, especially SpaceX and that kind of constellation satellites that they're having on astronomy, or could have in the future. And finally, thinking about those kind of theories that we use a lot in geography around kind of environmental justice, linked to space access or space equity and kind of who benefits from these technologies. So a lot of this, as I say, it's kind of started off as geography, but it quickly developed into an interdisciplinary module. And I think that this is in part because sustainability is something that we're all thinking about from our own different perspectives. So it's something that you can have a kind of shared discussion around. So the module seeded the University of Manchester Space Sustainability Network, and this it links geography, aerospace engineering, material sciences, physics, and hopefully more in the future. Effectively, I popped a Pete team because I found that actually kind of interdisciplinary groups, they work best around food and drink and socialising. And then actually we have these monthly meetings at the bar. There's a pub just next to this building called Sandbar, which is basically populated by academics. And we meet there every month. I find we don't talk about space that much, to be honest. But what's interesting is out of that, a lot of friendships have come, and we've had interdisciplinary research grants that have come out of that as well. So we've had the University of Manchester, both Manchester Sustainable Futures Research Grant and an UMRI grant as well, which is kind of leading on to UK RI grant application. So we try to get the students to be involved in that, so they feel that again, it's not kind of a niche thing, but they're involved in this broader community. And so we encourage them to join the monthly socials, the workshops that we run as well, and the hope is that they'll feel part of that kind of research community as well. And as I mentioned, it's becoming core to the space stream for the aerospace and engineering as well. So I think we're going to get about 20 students from that by the looks of things. So hopefully, that group's only going to get larger. Okay, so just a couple more slides. So what do the students gain from this? The main thing, I think, is they gain the tools to critically assess sustainability analysis in the space sector. To think about kind of what do we mean when we talk about space and sustainability. As I said, a lot of the literature until very recently was really about thinking about the very serious stuff in the space degree, but there's a much kind of broader discussion you can have as well in terms of, for example, life cycle assessment. They also get an experience kind of communicating ideas to public and policy audiences. So especially with the engineers, they're really good at what they do, and then it's kind of, I find it's actually really helpful for them to have that kind of ability to communicate outside of their own discipline, effectively, and to be able to speak about their ideas as well. There's an awareness of trade-offs and unintended consequences in sustainable innovation. So I think, as an example, if you're thinking about space debris and removing space debris, obviously you should also be thinking about the environmental cost of sending rockets up to do that as well. So it's kind of just that kind of wider perspective. And we do problem solving. So Kira McGrath and Nick Crisp come from engineering, and they talk about kind of sustainable mission design, and they give some problems around removing satellites from space, for example, from low Earth orbit. And finally, it supports engineers and environmental governance students in meeting new graduate competencies. And I mean that in kind of quite a broad sense in terms of thinking about, as I've said, about like issues in a broader context. There are challenges, however. A lot of these are quite technical. So I would say that the university aspires to be interdisciplinary in lots of different ways, in terms of, for example, research and teaching. But then in practice, it can be very difficult to get out of the silo that we're in institutionally. So in terms of writing this, I found there are very few shared materials for space sustainability. So I've kind of put it all together myself. The public awareness, and I'd say also kind of student awareness, as discussed, of the benefits and challenges of space, it remains limited. And obviously that has many kind of, I've talked about the difficulty of getting people to come on the course in the first place. In a broader context, we know what's happening kind of in the US with the administration, the NASA cuts, and it's like, to what extent are people really aware of how much these technologies and the kind of our working space actually connects with everyday lives. Interdisciplinary teaching is logistically challenging. So to give an example, cross-faculty timetabling, which I've just finished for next year, it's a challenge to get a seed module to be a core module in engineering, and partly it's because on the institutional side they haven't really done this before, and so that creates issues. This one's going to be interesting this year, I think, kind of harmonising assessment rules as well, something to think about, and understanding the internal processes to make a seed unit core in aerospace has been a story in itself, I would say. So concluding point, sustainability is an excellent space for interdisciplinary teaching because it engages engineers, social scientists and geographers alike, and I feel like we're all learning from each other. Students value the opportunity to work across disciplinary boundaries, and I think it gives them both technical and societal perspectives. It brings with it real challenges, as I said, so timetabling, assessment alignment and kind of curriculum integration take extra effort. And obviously we have very busy schedules, so that is something to bear in mind. But I would say the payoff is high, so that students leave with critical thinking skills, potentially systems understanding, and the ability to navigate complex global challenges. And finally, sharing teaching practice across disciplines and institutions is key. And I would think that the Space Universities Network, which I've recently discovered, would be able to play a key role there. Okay, well, thank you very much for inviting me, and does anyone have any questions?